This video will demonstrate how to find the equilibrium constant for the reaction of iron 3 and thiocyanate ion using a spectrometer. To begin, turn on the spectrometer by clicking on the Analyze Solution page within the spectrometer software. First, prepare your calibration solutions following the method given in the procedure, and then transfer these solutions to the individual cuvettes. You'll need to first rinse the cuvette with a small amount of the solution, and then fill the cuvette until it is about 2/3 full. When the cuvette is full, cover the cuvette with a cap. Repeat this process until all of the calibration solutions have been transferred to the cuvettes. After the calibration solutions are prepared, clean the surface of the cuvettes with a Kim wipe to remove any fingerprints. Calibrate the spectrometer by inserting a cuvette containing distilled water into the spectrometer, making sure the clear sides of the cuvette face the light source. Within the spectrometry software, click the Calibrate Dark button and then the Calibrate Light button. Once the calibration is complete, if you click the Record button to begin recording absorbances, you will see a straight line indicating that the sample is not absorbing any light. With the calibration complete, remove the distilled water and insert the first calibration sample into the spectrometer. Within the Analyze Solution page, press the Play button in order to start recording absorbances. Then use the Scale to Fit button and press Stop. Choose the Add Coordinates button. Your goal is to find the wavelength where absorbance is maximized. So presently the absorbance is 0.579, and you can use the arrows to change the wavelength slightly to the left or to the right and find where the absorbance is maximized. Here the maximum absorbance is 0.579, so choose the check button, and you can see that we set the analysis wavelength at 456 nanometers. With the wavelength set, switch to the concentration screen and then proceed to copy the concentrations of the iron 3 thiocyanate ion listed in your data table into the concentration column. You should note that you will have to overwrite the default concentrations. Your first calibration solution will still be in the spectrometer at this point, so once you finish entering all of your concentrations into the concentration column, you'll be ready to record absorbances. So just press the Record button, and the inlaid image confirms that you're working at 456 nanometers for wavelength. So when you're ready, click the Check button to accept the absorbance. Now remove your first calibration solution and replace it with your next calibration solution. Back in the software, you just have to hit the Check button again in order to accept the absorbance for this second calibration solution. Continue this process until you have recorded absorbances for all 5 of your calibration solutions. Notice that absorbance decreases as concentration decreases. Keep this in mind as you're measuring the absorbances from your own calibration solutions, and plan to recreate any calibration solutions that do not follow this trend. Once absorbances are recorded for all of your calibration solutions, you're ready to look at your Beer's Law plot, so click the Scale to Fit button and then the Linear Fit button. Hopefully your data will look like this data and fall neatly on a straight line, and as long as that's the case, your extinction coefficient will be the slope of the line, which here is 2290. Once you've finished recording the absorbances of your calibration solutions, you're ready to record the absorbances of your equilibrium solutions. Insert your first equilibrium solution into the spectrometer, and after the spectrometer has had a second to steady out, click the Check button to accept the absorbance. In order to calculate the concentration of the equilibrium solution, I would divide the absorbance of 0.27 by the extinction coefficient of 2290. After calculating the concentration, click the plus button to add another row to the table. Remove your first equilibrium solution from the spectrometer and insert the second one. Record its absorbance, and again calculate its concentration using the extinction coefficient. Continue this process until you have recorded the absorbances and calculated the concentrations for all 4 of your equilibrium solutions. Now that you've finished recording absorbances, press the Stop button, and then you can use the Auto Scale button if necessary to show all of your calibration solutions and equilibrium solutions on the same graph. Here I'm circling all of the equilibrium solutions, and you can see that their concentrations were well predicted by the calibration curve. At this point, you'll be able to use the data from your equilibrium solutions to calculate the equilibrium constant.